You are listening to the Think Brick Australia podcast. Think Brick Australia represents the clay, brick and paver manufacturers of Australia. Brick by brick, our podcast will discuss technical information and architectural case studies with special guests. I'm your host, Elizabeth McIntyre, the CEO of Think Brick Australia. On today's episode, we're going to talk about energy efficiency design and how we can passively design to improve the energy efficiency of our homes. And I'd like to welcome Michael Koungras, one of our senior structural engineers, to talk this through with me. Welcome, Michael.
Thanks for having me.
Michael, when we talk about energy efficient design, I think for me, it's really a translation of how a house performs as to how much I have to spend on utility bills to make the house more comfortable, whether that be cooler in summer or warmer in winter. How do you see energy efficient design?
Elizabeth, you're exactly right. When we're looking at designing a house energy efficiently, what we're doing is we're trying to implement best design practices to reduce the reliance on artificial heating and cooling. Because as a homeowner, we all don't like bills. And the more we can implement passive design practices to keep our house at a thermal comfort level, the more comfortable we are and the better it is for our back pocket.
One of the things that I've learned during my time studying energy efficiency is there's a real misconception around what it costs to heat or cool a house. And in fact, it's actually when you heat a house that you spend more money on. If you think in winter, you've got to close all the doors, you've got to heat the house, that heating's got to flow through. Whereas sometimes you can just open windows and get fans moving, but heating actually costs a lot more in terms of utility usage. Anyway, we're going to go into that a little bit more, but what other factors contribute to energy usage, Michael?
Yeah, there are a range of factors which we can look at to optimize the energy efficiency performance of a home. First of all, orientation is a big part. And so north facing is ideal, but trying to get our home as close to north facing as possible.
And that's really hard though, Michael, because, a lot of times when people are buying land and house packages, they don't get to put their house with the driveway coming up the middle of the lot.
You're exactly right, which leads me on to my next point, which is floor plan. So even if we can't have our north-facing block, we can lay out the home in a way which maximizes that north orientation.
Now, the next thing we are going to talk about is windows, and they are the devil in design, really, because windows do allow a lot of thermal mass to leave a building.
Windows are awesome because they allow light and heat to come in, but they also, as a material, allows the transfer of energy really easily compared to other materials. So making sure we put windows in the right locations around the building to maximize that energy input.
And that's always really hard, isn't it, Michael? Because we often want windows so we can see the view outside or not. What's the next thing that we need to look at?
The next one is probably one of the biggest design factors when looking at energy efficiency design, and that's material selection. And that goes all the way from the external facade through to the roofing material and the flooring material as well, and both internal and external walls. So really understanding the orientation and the floor plan of the house, and then putting the right materials in the right places to maximize the energy efficiency.
Everyone talks about insulation, and again, where does insulation fit, Michael?
In a few places. So absolutely in our external walls to increase the energy performance of our external facade systems. We know that the introduction of insulation into any wall system improves the overall energy performance of that system, but our roofs as well. And so using ceiling insulation and roofing insulation in conjunction with one another ensures that in summer, that heat isn't entering our home, but also in winter that the heat within our home is captured and not lost through the roofing system to keep that thermal comfort level at an optimum level.
And Michael, that really brings me to our next point. There's a lot of building materials that are used together with insulation so that they could have a thermal mass that could be equal to brick. But let's talk about what thermal performance does.
So thermal performance is how our materials rate, essentially. And we know that thermal mass in homes in a country like Australia where we have hot summers and cool winters is a really important factor in maintaining that internal temperature at a thermal comfort level. And so using bricks as our external facade material, in summer, they absorb the heat to keep the internal temperature cool. But in winter, what they do is they also absorb the heat, but they maximize the energy output of the sun by storing that heat in the walls so that when the temperature cools down at night, that heat is slowly released into the home to maximize the energy efficiency.
And we call that the lag effect, isn't that right?
Yeah, thermal lag. And so what we're doing is we're harnessing the warm day and making sure that energy is captured and released throughout the cool night.
So, Michael, I know for me, I'm really confused by a lot of the acronyms that are used with regards to energy. And certainly in my time in the industry, there's been a whole lot of different ways of how things could be rated. But let's talk about how the National Construction Code deals with the energy efficiency standards.
So the National Construction Code, the NCC, has a dedicated energy efficiency section. And this section goes into how we can achieve high-performing homes. And if you think about on a washer or a dryer where you see that star rating on the energy efficiency or the water usage of a washing machine, houses are no different. And what the NCC, in conjunction with NABERS, which stands for the Nationwide House Energy Rating Scheme, does, is by putting all these factors into taking all these factors into account, it gives you a star rating on how that home will perform. And that takes into account everything that we said earlier, which is orientation and external building materials and insulation and location as well. So keeping in mind that different houses in different parts of Australia will perform differently because of the different climatic zones. And it takes all these into account and gives us a star rating. And the higher the star rating, the better performing our home is.
So, Michael, when we're talking stars, I like to refer to these normally as in hotels, but we'll talk about stars now. What star rating should we be aiming for when we're building a house?
So when we're building a house, we should be aiming for an overall performance of 6 stars.
6-star house. I know there are some out there for 8 stars, but
obviously, the higher the star rating, the more energy efficient the house is, and the better it will be for the homeowner. But as a bare minimum, the NCC requires all houses to have a minimum value of 6 stars.
Great. And then there's a lot of other different authorities in each different state. I know we're in New South Wales, and the authority that oversees the rating of buildings is BASIX. What oversees commercial buildings?
Yeah, so for commercial buildings, an acronym called NABERS, which stands for the National Australian Built Environment Rating, is used to verify energy efficiency, but all these systems still work towards the same overall outcome of achieving a star performance rating to ensure that that building meets a minimum set of requirements.
Can you just take us through the National Construction Code for 2022 has a real emphasis on energy efficiency in buildings. What are some of the changes that have come about to reflect this?
So what we're seeing now as more information and research has been conducted into this field is that prior to the NCC 2022, we were looking at an overall star performance of a house, and that was 6 stars. But what we're seeing now is that there's been a bit more emphasis on separate heating and cooling components of how the house performs. So in Australia, especially on the East Coast, which is our most densely populated area, we do have hot summers and cool winters. And so the house has to perform reasonably in both. We can't just make it really good in summer and poor in winter. And so now, in order to achieve the minimum set of requirements, we have to maintain our overall 6-star accreditation, but there are still minimum star ratings imposed to purely based on heating and purely based on cooling. And if you don't obtain all 3 components, the heating component, the cooling component, and the overall component, the house is not deemed to be energy efficient. So we do have to pass all 3 components of the new star system.
And I think that differs in the past because if I understand it very simply, you used to be able to combine your heating and your cooling. So say, for example, you had heating at 4, cooling at 2. You could combine that to come out with 3 average, whereas that's no longer applicable.
Correct. And what we've seen in the past is people doing 6 and 0, where a house was really cool in summer, but come winter time, it was freezing. And to now ensure that that house performs more evenly throughout the entire year, we have the minimum heating, the minimum cooling, and the overall performance.
Because we are thinking bricks, for energy efficiency, why do bricks make the best choice?
Bricks make a fantastic choice for 2 main reasons. The first reason is that they have low embodied carbon compared to other materials. So if we look at the embodied carbon, which is the amount of carbon stored within the material itself, bricks come in at around 2.5 megajoules per kilo, compared to products like steel or paint, which are 30 or more megajoules per kilo. So as a building material, low embodied carbon is, first of all, why they're a fantastic environmental and energy efficient choice. But one of the main reasons why bricks are fantastic in implementing into your energy efficient design is because they have a high thermal mass. And we talked about that earlier, but to go into a little bit further, they're like a battery for your home, and they store that heat and release it at a more appropriate time. And so in summer, when we want it to be cool inside because it's really hot outside, the bricks will absorb that energy to keep the internal temperature cool. And once it cools down, they will release it more slowly. So on a hot day in summer, the bricks will store that energy, keeping the internal temperature cool. And when it cools down outside, they will slowly release that energy. But in winter, when we do want the internal temperature to be warmer than our external temperature, they will harness the energy of the sun by storing that within the bricks themselves and release them more slowly to keep our internal temperature at a level higher than the external temperature.
It also means as well, I guess if you've heated a room that's a brick room, it's going to stay heated that little bit longer and release that slowly to the outside.
Absolutely. And when it comes to energy efficient design, we want to flatten the curve. We don't want high peaks and troughs because that's energy coming in and being lost really quickly. We want that energy to stay within the home, keep it warm, which will reduce our reliance on artificial heating. And ideally, that's what energy efficient design is about, reducing the need for artificial heating and cooling.
And one of the most amazing things about masonry, Michael, is that we talked about some other materials having to use insulation just to get to that thermal mass level that a single brick has. We know in areas like Western Australia where they have these extreme temperatures that they can do a double cavity brick design, but that they can also, if they wanted to, further increase that energy efficiency by insulating within the cavity brick and some other insulation properties. The thing about brick is you're able to get to that energy efficiency very, very quickly. And if you wanted to enhance it even more, you can get to those 8 or 9 stars by doing that.
Yeah, you're exactly right. We've got a range of different brick systems available to us. So we can use a brick veneer home. We can incorporate insulation to brick veneer, double brick, insulated double brick. As a minimum, a lot of the houses that are modelled within NABERS are based on a brick home. And so by using bricks, we can definitely achieve our Energy Star rating. But when we talk about 7-star and 8-star, by the addition of insulation into these systems, we can far exceed the minimum performance required.
The easiest way to achieve energy efficiency in a house or a building is to think brick.
Absolutely.
Thank you, Michael.
Thank you.
If you have enjoyed this podcast, please follow, rate, and review our podcast. We are always looking for new ways to think brick. If you have an idea of what you'd like to hear about, there's a link in our show notes to let us know.